Hi students. So today we're starting chemical reactions. So this one of the things we've been leading up to, from matter to atoms to elements to the periodic table and physical properties and chemical properties, and how do you know if a chemical reaction took place versus a physical change? How do you know if a chemical change took place or a physical change? Chemical change takes place through chemical reactions. So yeah, we've been through a lot of material since January, and now we're going to be putting some more of it to use, just like in the last chapter. So those foundation pieces were really important, just like I said. All right, so the new material is about chemical reactions. So what's a chemical reaction? It's when you take different reactants, things that could react under certain conditions, and create new products. So if you've ever done the vinegar and baking soda, you mix vinegar and baking soda and you have a chemical reaction take place. You can see it, there's bubbles, you can smell it, and the smell changes. It goes from the vinegar smell to really no smell in the product side. So those are indicators, which we learned about chemical change indicators, and they review them in this lesson. That's an indicator that a chemical reaction or a chemical change took place. So now we're going to get to the nitty-gritty. So we have chemical formulas tell us, with the subscripts, tell us the number of each type of element, the number of atoms of each type of element are in that chemical formula. Okay? So one of the things that we're going to focus on in this lesson, we're going to learn chemical reactions and how they take place and what's happening, but we're also going to learn how to use them to prove the law of conservation of mass. You can't create or destroy matter on either side of that arrow. You have to account for every single atom. So in order to account for every single atom, you have to be able to count the atoms. So that'll be something that we're going to work harder on tomorrow. Starting tomorrow, we're going to really dive into that tomorrow. How do we count the atoms? How do we balance the equation? I'm going to do a real easy one here. And after I do this one, maybe some of you will have an aha moment. Some of you will need additional time with it, and that's what tomorrow will be. All right? So getting the vocabulary down for lesson one, your reactants are on the left side of the equation. Reactant, those are things that you're going to put together to see if they will react. They'll change, make some changes, okay? The arrow, this textbook calls it produces. Some of them say yields, but this textbook says produces. It's kind of like an equal sign in math, kind of. Don't use an equal sign though. Use the correct science symbols, okay? So produces and then products. So we mix our reactants and then they produce products on the other side. Reactants produce products. That kind of makes sense, right? Reactants produce products. There you go. All right. These are all chemical formulas, right? These are subscripts. You should have already known what a subscript is. This means there are 2 atoms of oxygen, and this means there's 1 carbon and 4 hydrogen. 1 carbon, 2 oxygen, 2 hydrogen, 1 oxygen. All right. This whole thing then is called a chemical equation showing a chemical reaction. So this whole thing is a chemical equation showing a chemical reaction. All right. So you are not allowed to change subscripts. For example, you know this is water. If I change that subscript, it's no longer water. So in order to balance the chemical equation, we'd use coefficients. This is a math term you should already know. Coefficients are a number that you would put in front. And when you put it in front, it multiplies times everything behind it. So it's almost like these are in parentheses. It multiplies times everything after it. So I'm gonna go ahead and balance this equation for you, because it is not balanced right now. Because on this side I have 1 carbon, and on this side I have 1 carbon, check. This side I have 4 hydrogen, but on this side I only have 2 accounted for. So I'm going to start there. What times 2 equals 4? And that's my first thinking. And I always use pencil for these, not on the board, but when you're doing them on your paper, always use pencil, because you're probably going to have to erase on some of them, because it gets complicated sometimes, and that makes them fun. They're like a puzzle, solving a mystery. All right, so we'll put a 2 there. So now I have 4 hydrogen. Well, I have 2 oxygen here and 1 here, so I have a total, well, now I have 2 times 1. So now I have 2 plus 2, I have 4 oxygen altogether, because this goes times that as well. So I have 2 oxygen here, because this means I have 2 H2Os. I have 2 H2Os. So that means I have a total of 4 hydrogen, which is good. Yay, that checks. And I have a total of 2 oxygen. Do you see it? Okay. So that means I have 2 of that molecule. All right, so 2 oxygen here, 2 oxygen here, make a total of 4 oxygen. Well, over here I only had 2 oxygen, but that's an easy fix. I can put a coefficient. You can always use coefficients. I can't change that to a 4, because that's not the same molecule. O4 is not the same molecule as O2. So don't be touching subscripts. You can only use coefficients, which go in front. So 2 times 2 is 4. So now this is actually a balanced equation, and what that does is prove the law of conservation of mass, which is another idea in this particular lesson that you're reading. All right, I think that's it in a nutshell, and then tomorrow we're going to do some more of it. You have a content practice to do from your guided reading from yesterday. If you had any questions on the guided reading, you can ask me tomorrow, okay? You can ask me about it tomorrow. You have a content practice, and it says each term is used only once. And it's walking you through, it's going to walk you through steps of different chemical equations, and you're trying to get some ideas. You're trying to put ideas in there. What is this part? Okay. So this is an atom of the element carbon. This is an atom of the element carbon. It's on the product. It's also a product. It's also a reactant. It has to be on both sides. You can't gain or lose anything. Law of conservation of mass. I think, these are compounds, right? These are compounds. This particular compound is a molecule because it has a covalent bond. All right, I think that is everything that will help you complete that little mini task that you have today. Have a wonderful day. It's going to be warmer, so maybe you can get outside.